Welcome, students, to another 6th grade math episode with your host, Mr. Nerlich. Now, today we're going to be working with lesson 4.1. And the reason it's only part 1 today is because I wanted to give you lesson 4.1 in several parts to make it more manageable and so that you have time to fully understand one part before moving on to the next. Without further ado, we're going to start with multiplying fractions. And when you multiply fractions, simply all we do is multiply the numerators and then multiply the denominators. So we multiply our numerators and then we multiply our denominators. Okay? And then when we're done, we're left with a numerator over a denominator. You're done, right? Not quite. The next thing you must do, and that's why I put must in all caps, is simplify. So we must simplify. And I know some of you are thinking, but I got the right answer, it's just not simplified. Well, you did, but we always want to write our answers in the most basic form or simplest form. And the reason for that is, here's an example. So let's say you are baking a cake, and the cake calls for 16/64 of a teaspoon of salt. And you look at your parents and go, Mom, Dad, what's 16 over 64? And they go, we don't have a 64th of a teaspoon. And then you go, okay, well, let me get on Amazon. So maybe you do. You find a 64th of a teaspoon on Amazon to make your cake. You just don't make your cake that day. You wait till another day. And you're like, I got my 64th of a teaspoon. And now I'm going to do 16 of these little teeny tiny things that's smaller than a drop. And you're going to do that 16 times. Or you can get a 1/4 teaspoon, which almost every kitchen should have, and you pull it out and you scoop it once. I don't know about you, I'd rather scoop one time 1/4 of a teaspoon than 16 of the 64th of a teaspoon. But if you didn't simplify, you wouldn't know. And that's the nice thing, is that recipes will simplify it for you so that you have the exact measurement you need in the least amount of scoops to make it as simple as they can for you. Because no one wants to measure something 16 times. Shoot, I'd probably forget what number I was on and put in only 12 or 20 because I wouldn't remember I was on 16. So that's why simplifying is super important. Okay, so we have two ways to simplify. One is to divide the numerator and denominator by the GCF. You thought you can get rid of the GCF, did you? Well, it's back. And what's cool is you already know how to find the GCF. So then dividing by the GCF won't be anything new. It's just one extra step that you're like, I already know this. So I just have to recall my information and apply it. And if you kept your notes, which everyone should always keep their notes, then you look back, go, oh yeah, I got to make that Venn diagram thingy, and then I'm good to go. And there you go. Now, the second way to find your simplest form of your fraction is to cross cancel or use cross canceling. This is the way I prefer to do it, but again, I'm your teacher, and so what may be the best way for me may not be the best way for you. So if you want to find the GCF and divide by the GCF, go ahead, be my guest. I mean, that's awesome. I like cross canceling because I can kind of see how to simplify really quickly cross canceling, and sometimes GCF takes a little longer, but it's totally up to you. So let's look at an example. So example number 1. For example 1, we have 3/4 times 8/5. Okay, and we know that that equals, by multiplying across our numerators and then our denominators, we end up with 24 over 20. All right, so the first way we're going to simplify this is with the GCF. Now, before I got on here and started recording, I did do the Venn diagram and found that the GCF was 4. So that's going to save us some much needed time. And 24 divided by 4 equals 6. And 20 divided by 4 is 5, so we get 6/5. And you are never, ever, ever allowed to leave an improper fraction as your answer. We must always change it into a mixed number. And so we ask ourselves, how many times does 5 go into 6 without going over? 1 time. And then how much is, so then 6 minus 5 gets me 1. So I have 1 left over, and I have 1 1/5. All right, so that's our answer, 1 1/5. Now, here's the cross-canceling way to solve this. And if you think this is easier, great. If you think it's not easier, then totally use the GCF. You will not hurt my feelings just because this is my preferred way to do it. I just want to show you multiple ways to solve it and let you choose. All right, so when I look at this, I try to see, are there any numbers that could fit into another number diagonally? And when you cross cancel, it's just like the x. We have to cross cancel either the 3 and the 5 with each other or the 4 and the 8. So that's the only way we can cross cancel, because an x makes a cross cancel. So that's how we're going to do this. So I'm going to look and I say, can I fit 3 into 5 evenly? And the answer is no. And I obviously cannot fit 5 into 3 evenly because 5 is bigger. So that doesn't work. So I can't cross cancel the 5 and the 3. But then I ask, how many times can I fit 4 into 8? And I look and I go, let's see. If I do my multiples of 4, I almost said skip counting. See, even your teacher makes mistakes. If I count or do my multiples of 4, I go 4, 8. So 4 goes into 8 2 times, which means 8 becomes a 2. And how many times does 4 go into 4? Once. So it becomes a 1. Now look at that. Now all I have is 3 times 2 over 1 times 5. Now I don't know about you, but I think multiplying 3 times 2 and 1 times 5 is easier than even doing this, and I didn't have to find the GCF. But that's totally up to you, and sometimes, the GCF has maybe even a little easier than this way because you can't really see a way to simplify here, so then you do the GCF. Both ways are fine. Equals 6/5, which equals 1 1/5. All right. Now, we're going to do some more multiplying, but we're going to multiply by whole numbers with fractions. So to do this, we have to turn the whole number into a fraction by giving it a, what do we think we want to give it? Denominator of 1. Very good. So we want to give it a denominator I bet, because of my pause, quite a few of you honestly said the answer out loud, which is awesome. And if you didn't, that's okay too. But sometimes I will pause just to see if I, can get some of you to just, oh, I said the answer out loud without even thinking about it, which is great. All right, so we give it a denominator of 1. Then you solve like you would multiplying fractions. So we're going to solve it the same way like you would multiplying fractions. So basically, we have a fraction and a whole number. We make the whole number look like a fraction, and then we multiply like we just did with fractions. That's all we do. So we just change how the whole number looks by putting a division bar, a fraction bar, and a 1 on the bottom, and voila, we got a fraction, and then we multiply like we know how to do. All right, so let's look at example number 2, and let's see how we can multiply a whole number by a fraction. So I have 1/7, and I'm going to multiply that by 14. Okay. We want to change the whole number to a fraction, and we said the way to do that was to take and put a denominator of 1. So if I rewrite this, I will have this will equal 1/7 times 14 over 1. Ta-da! Now I have two fractions, and guess what? We know how to multiply that. So now, and I put these lines here, this just, well, you know, you want to fill in your answers here. So 1/7 and 14 over 1 is what we just filled in on your guided notes. Now what's really cool is I'm going to cross cancel this because I know that 7 goes into 14 two times evenly. And I know that 7 obviously goes into 7 one time evenly. So now I have 1 times 2, which equals 2, and 1 times 1, which equals 1, and I'm left with 2 over 1, which equals 2. And that's my answer, 2. Pretty simple, right? I mean, we just made the whole number look like another fraction, multiplied, used one of our simplifying techniques, and voila, we get an answer. Okay, so now what do you do if you have to multiply by a mixed number in a fraction? Oh, no, not a mixed number. Oh, Mr. Nerlich, you're driving me crazy. I know. I'm sorry. This is a lot. This is why, again, in the beginning, I said we're going to break it into 2 parts. This is why. There's a lot to each of these parts. All right, so we're going to break it into a mixed number. We're going to break a mixed number down so that it looks like a fraction, okay? So then once we break it down to a fraction, we do the same thing like we're multiplying fractions. There's a common theme here. We are going to be multiplying a lot of fractions by fractions. All right. However, we have to get mad first, okay? So we want to get mad first. M-A-D, mad. And you're probably wondering, want to get mad? Why do I want to get mad? Well, I don't know, maybe because we had to multiply by fractions, then multiply by a whole number, and then multiply by mixed numbers. I mean, that's a good reason to get mad, right? You're like, all this math is so much. Well, it's not necessarily means get mad like angry. It means this strategy, okay? So we're going to look at an example. I'm going to show you how to get mad the right way to help you solve it. So for example 3, we have 2 and 3/4. Oh boy, there's that ugly mixed number. And we're going to multiply it by 1/2. All right, so yeah, I honestly can't multiply this how it is without changing and getting mad, without getting mad first. There's you know, I mean, if I really looked at it, I probably could eventually figure it out, but it would take me forever, and it's not something I really want to do. It's not pretty. But if you get mad, no, not that mad, just this kind of mad, then you can solve it. So when we get mad, we're going to write it out like this, okay? And so when we get mad, we want to multiply. The first thing we're going to do is multiply. Then we're going to add, and then we're going to keep the denominator. And you're like, multiply what? Add what? Denominator where? Well, we're going to multiply 2 times 4 and then we're going to add 3 and keep the denominator 4. And I always like to draw a little arrow that goes around. And show us the way we want to go around to do this problem. So if we get mad for 2 and 3/4, okay, let's get mad. So I have my 4 times 2, which equals 8. And then I have 8 plus 3, which equals 11. And then I keep my denominator, and I have 11 over 4. So now I just got mad, and I found out that when I get mad for 2 and 3/4, I get 11 over 4, or 11/4. It's awesome. So now I have 11/4. Now I can multiply 11/4 times 1/2. And unfortunately, I can't cross cancel. And there really is no way to use the GCF to simplify this. So we're just going to multiply across. And we're going to get 11 over 8. However, I do have to change it back to a mixed number because we can never leave an improper fraction like this. It's improper. And you always want to be proper when you come into school. You always want to be proper when you go visit your grandparents or you're in church or something like that. You want to be proper when you have people like your elders. You want to be respectful and proper. And we can't be proper if we are improper, correct? So, here's how we solve this. We say, how many times does 8 go into 11? 1 time. 11 minus 8 is 3. So I have 3 over 8. My answer is 1 and 3/8. Okay. All right, now we have some for you to try on your own. And let me tell you, it's a lot of the same stuff again, which you clearly know how to do. Good luck, Falcons. You got this, and you're going to be ready to go for when part 2 of lesson 4.1 comes. Have a stupendous day. See you later.